Hello everyone, welcome to my presentation. I am Sangeeta studying in Sri Venkateswara College of Engineering from the Department of Computer Science and Engineering. Today we are going to discuss about software engineering and project management. And today's topic is serverless computing in software development. It is a comprehensive exploration. This was a research paper which was published in IEEE Explorer in the year 2017. In this presentation, let's briefly understand about this research paper. This presentation delves into the world of serverless computing and its impact on software development. We will explore the fundamental concepts, reviewing existing research, and examine the benefits and challenges associated with this paradigm shift. This analysis will be grounded in a robust research methodology, culminating in a comprehensive overview of current trends and future possibilities. Abstract, objective. To comprehensively analyze the impact of serverless computing on software development, methodology is exploring its benefits, limitations, and potential future directions. Scope. The research focuses on exploring the current state of serverless computing, examine its adoption in real-world software projects, and identifying key trends and challenges. Methodology. The study employs a combination of literature review, case studies, and expert interviews to gather insights and develop a comprehensive understanding of serverless computing. Key findings. This research highlights the potential of serverless computing to improve development efficiency, scalability, and cost effectiveness, while also identifying challenges related to security, vendor lock-in, and debugging. Introduction to computing. Serverless computing. It is a cloud-based execution model where the cloud provider manages the underlying infrastructure, including servers, operating system, and resource allocation. This allows developers to focus on writing code without worrying about server management. Function as a service. FAAS is a core component of serverless computing. Developers write small independent functions that can be triggered by events such as user actions or data updates. The cloud provider automatically scales and manages these functions, ensuring optimal performance and resource utilization. Serverless architecture. A serverless architecture involves building applications using a collection of independent functions. This allows for greater flexibility, scalability, and fault tolerance compared to traditional monolithic architectures. Literature survey on serverless computing. So, what are the literature surveys that the research paper contains in serverless computing is the technical aspects. The research in this area focuses on the technical foundation and implementation of serverless computing. This includes topics like function execution models, resource allocation, scalability, and fault tolerance. The researchers explores various architectures such as serverless containers and edge computing to optimize performance and cost efficiency. Application and adoption. This research focuses on the practical applications and real world adoption of serverless computing. Studies analyze the impact of serverless technologies on software development processes, including development methodologies, deployment strategies, and testing frameworks. Researchers also investigate the challenges and opportunities associated with adopting serverless computing in different industries and use cases. Research methodology. Literature review, expert interviews, case studies, and data analysis and synthesis. These are the research methodology that comes under serverless computing in software development. The first one is literature review. A comprehensive review of existing research on serverless computing, including its technical aspects, application in software development, and its benefits and challenges. This step involved analyzing academic articles, industry reports, and technical documentations to, to gain a thorough understanding of the current state of the field. The second one is case studies, an analysis of real world projects that have successfully adopted serverless computing, highlighting the practical benefits and challenges experienced by developers and organizations. These case studies provides valuable insights into the implementation and adoption of serverless computing in different contexts and industries. Expert interviews. Interviews with experts in serverless computing, including developers, architects, and researchers, to gather insights on industry trends, best practices, and future direction. This step provides valuable qualitative data that complements the quantitative analysis from literature review and case studies. Data analysis and synthesis. A systematic analysis and synthesis of the data collected from the literature review, case studies, and expert interviews. This step involves identifying key themes, trends, and insights that contribute to a comprehensive understanding of serverless computing impact on software development. Advantages of serverless computing. The four main advantages of serverless computing are enhanced scalability, cost optimization, increased developer productivity, improved security. The first one is enhanced scalability. Serverless computing provides automatic scaling based on demand, ensuring that your application can handle spikes in traffic without performance degradation. This eliminates the need for manual infrastructure management and allows for effortless scaling up or down as needed. Cost optimization. You pay only for the resource you consume, resulting in significant cost savings compared to traditional server based architectures. Increase developer productivity. Developers can focus on building business logic and functionality without being bogged down by server management tasks. Improved security. Cloud providers handle security infrastructure and patching, reducing the burden on developers and ensuring a more secure environment for your applications. Challenges and limitations of serverless computing. Vendor lock-in, cold starts, debugging and monitoring, security and concerns. These are the disadvantages of serverless computing. The first one is vendor lock-in. What is this challenge? Let us briefly understand. Serverless computing is typically tied to specific cloud providers which can create vendor lock-in. This make it challenging to switch providers later, potentially limiting flexibility and potentially increasing costs. Cold starts. Cold starts occur when a serverless function is invoked for the first time after a period of inactivity. The function needs to be initialized, which can lead to latency and slow response times, especially for frequently used functions. Debugging and monitoring. Debugging serverless applications can be more challenging than traditional applications due to the lack of direct access to the underlying infrastructure. Monitoring serverless application requires specialized tools and techniques to track performance, resource utilization, and error logs. To maintain a serverless computing, we need a different applications which is required for monitoring that serverless computing. So that may be our challenges of using a serverless computing. Next is security concerns. Serverless environments introduce new security challenges related to function isolation, data access, and vulnerability management. Developers need to aware of these vulnerabilities and implement appropriate security measures to protect their applications and data. Case studies on serverless computing. So, few examples of that serverless computing where all these computing without servers are used is Netflix, Uber, and Airbnb. Netflix, a leading streaming platform, leverages serverless computing to manage its vast infrastructure and deliver high quality streaming services. They employ serverless function to process user requests, manage content delivery, and scale their platform dynamically. Their adoption of serverless technology allows them to handle peak demands during popular show releases, ensuring consistent performance and user experience. Uber, a global ride-hailing service, utilizes serverless computing to manage its complex system of drivers, riders, and payments. They rely on serverless function to process requests, optimize routes, and manage payments in real time. Their use of serverless architecture allows them to scale their platform rapidly to meet fluctuating demand, ensuring a seamless experience for users. Airbnb. Airbnb, a global marketplace for accommodation, leverages serverless computing to manage its rapidly growing platform and cater to a diverse user base. They utilize serverless functions to process booking requests, manage user authentication, and scale their platform dynamically. Their implementation of serverless architectures allow them to handle peak booking periods efficiently, providing a reliable and responsive platforms for both host and guests. Future trends and opportunities in serverless computing, edge computing and serverless security advancements, serverless for AI and machine learning, serverless for web 3 and decentralized applications. These are the future trends in serverless computing in software development. Conclusion, transformative impact, efficiency and scalability, future potential. Thank you.